Hey guys, this is the last section. I'm grading the test so far. I'm doing this video Monday, and the quizzes, and they look pretty good. Y'all are understanding the math. The units are what's hurting you always. Um, when you're talking about momentum, it's kilograms times meters per second squared. What most of you are getting confused is that a Newton is equal to a kilogram times meters per second squared. Momentum is kilograms times meters per second. So that's a big one. So make sure we all know that one. All right, so section 4 is universal forces. There are 4 universal forces. One, electromagnetic. Electromagnetic. There's 2 words there. Electric, magnetic forces. Strong nuclear forces, weak nuclear forces, and gravitational forces. Electromagnetic forces, they are associated with charged particles. So the electric and the magnetic force are the only forces that can both attract and repel. So electric and magnetic forces are the only ones that can attract and repel. So electric forces act between charged particles or objects such as electrons and protons. So you know that if you have a positive and a positive, they're going to repel. You know that they have a negative and a positive, they're going to be attracted. Same thing with magnetic forces. On certain materials, on certain metals, they have poles of magnets and are moving charges. So you have a north end or south end or south pole of a magnet. You know that the south and the south are going to repel, north and north are going to repel. So it's like when you played with your Thomas the Train that had the little magnets on the end of it. I don't know if y'all play with this. If you put the 2 heads together, they are repelled. If you put a head and a tail together, they're attracted. So electromagnetic forces, electric forces, magnetic forces. The only ones that can both attract and repel forces. All right, so nuclear forces, there's 2 of those, strong nuclear forces and weak nuclear forces. So the strong nuclear force, that's a powerful force of attraction, because it's called strong, that acts only on neutrons and protons in the nucleus, and it holds them together. So the neutrons and protons are not attracted to each other. They're not repelled, but they're not attracted to each other. So this is what actually holds them together in the nucleus. So that the neutrons and the protons in the nucleus can actually be held together. Weak nuclear force is an attractive force that only acts over a short range. This can also be radioactive material that start to break down. All right, the third one is gravitational force. This is an attractive force, acts between any 2 masses. Them being attracted depends on mass and distance. So if you increase the mass, you're going to increase the gravitational force. So again, if you've got the moon and Earth, those have huge masses. But if you were, let's say we added some mass to the moon, the gravitational force would increase. Okay, if I were to take some mass off of the moon, then the gravitational forces would be decreased. So also distance is a factor. So if I increase the distance, it also decreases the gravitational force. So if I were to move the moon away from the Earth, then you would have less gravitational force. But if I were to if I were to bring it closer, I would have increased gravitational force. Out of the 4 universal forces, gravitational force is actually the weakest because, like I said earlier, I think even you and another person have gravitational force with each other, but we don't notice it because the gravitational force is so weak. I mean, like when you are standing in a tree, you're not being pulled down. I mean, once you get off, when you jump off, you're being pulled down, but you don't feel being pulled down. So this is why gravitational forces are the weakest. This is called centripetal force, not centripetal. Centripetal force is a center-directed force that continuously changes the direction of an object to make it move around a circle or a center. So this would be like a satellite. This would be orbiting, like the moon orbiting around us. This could also be like, you ever taken a bucket full of water or sand and you grab it by the handle and you start swinging it around and the water and the sand stay in the bucket, that's centripetal force. Or like when you go to the fair or the carnival and you're like on those like teacups or some of those rides that you're spinning around, you're not flying out, you're being pushed back towards the seat, but you don't fall out. This is centripetal force. So that is it. So I'm going to give you a study guide, and you're going to have Wednesday to work on it. Okay.